Hello, my name is Emily Grieve, and this is a pre-recorded presentation for the 2020 International Conference on Cognitive Modeling. We were interested in investigating individual expert microstrategies in routine tasks. To do this, we developed a game based on ESCOM's microstrategies and had one participant trained to become an expert at it. We also built a predictive cognitive model in Python ActR with an ESCOM's knowledge structure to be an expert at the game. Before becoming an expert, the participant first had to learn how to play the game, starting with the methods. For our game, the methods consisted of 8 different 2-letter sequences that corresponded to a 4-digit response. For example, RP was one of our methods, and the response is 4321. Once the participant has memorized all 8 methods, they move up to the unit task level. The unit tasks are 3 sequences of methods in specific orders. The player can recognize the unit task by the first method, which will not appear anywhere else in the sequence. After the unit task level, the player must learn the planning unit level, in which the unit tasks come in specific orders. The player is considered an expert when they can see the first method of a planning unit and know the order that the unit tasks, and by extension the methods, will come in. Our predictions are based on the ActR model and previous results from the West et al. 2018 study. Reaction time was based on how fast it takes for the participant to enter the corresponding 4-digit sequence from when the 2-digit code first appears on the screen. We predicted that reaction time will differ significantly depending on whether the next method could be memorized, known, or whether it is necessary to see the code before responding, unknown. For the unknown conditions, our model correctly predicted that method signaling the beginning of a planning unit will take more time as opposed to an unknown method that is not associated with the beginning of a planning unit. We believe this is due to the ESCOM's overhead required to keep track of the planning unit. For the unknown conditions with multiple possible responses, we predicted that Hicks' law, which states reaction times increase as the number of stimulus response alternatives increase, would not apply. Specifically, we predicted no difference between our 3-choice and 2-choice conditions because the model assumes expert players will not rely on declarative memory. For the known condition, the model correctly predicts that a method signaling the beginning of a unit task will take more time due to the ESCOM's overhead required to keep track of the unit task as opposed to the method not associated with the beginning of a unit task. We also compared our results to the West et al. 2018 data, where their players played a similar but different game. In this visual, we are comparing the players to an ActR optimal model, which does not keep track of where in the game the player is, and an ESCOM's ActR model, which assumes players keep track of their place in the game and therefore adds overhead. We assumed that differences in speed were due to differences in perceptual motor time. The perceptual motor times were then calibrated to the fastest player for all 3 players for the known and unknown methods. Looking at the planning unit start condition, our results match the other players and the ESCOM's model within milliseconds of accuracy. In the unit task start, our results do not match those of the player or models in this condition. However, they do match the player and models in the unknown condition. We concluded that this is due to the player adopting a different microstrategy, where they look at the code at the beginning of the unit task before responding. As the player we used in this study, I can confirm this is the strategy I was doing. The game we developed is significantly harder than that of West et al. 2018. Our game has no indicator for the beginning and end of planning units, leaving it up to the participant to track. We think this may have contributed to this difference in microstrategy. What this research shows is there is a strong tendency for people to keep track of where they are in the task, as predicted by ESCOM's and the overhead. In conclusion, individuals do use different microstrategies, and we can and should make models of the individuals and their microstrategies. Thank you for listening.